In this class, now I am going to explain 2022 advanced question from complex numbers. See that question. Find the number of distinct complex roots of this equation. Z bar minus Z square, which is equal to I into Z bar plus Z square. This is the equation whose roots we have to determine. That roots must be distinct complex roots. Okay. Now how many distinct complex roots does it have? This is an equation. Now solve it. See how I am going to solve it. Z bar minus Z square. Now multiply these two with I into Z bar and I into Z square. Now bring it to the left side. Z bar minus I into Z bar. When it goes to the right side, Z square plus I into Z square. Now take Z bar common from this. You get 1 minus I into Z bar, which is equal to, when you take Z square common, 1 plus I into Z square. Now transfer this one to the right side so that you get Z bar is equal to 1 plus I by 1 minus I into Z square. Now simplify this. 1 plus I by 1 minus I. Now multiply numerator and denominator with conjugate of this. So here 1 plus I by 1 plus I. Now simplify. On simplifying, denominator is going to be 2. And what about numerator? 1 plus I whole square, which becomes 1 plus I square. I square is equal to minus 1 plus 2I. Now both of them cancel. 2 cancel. I is left. Now write that I here. Z bar, which is equal to I into Z square. Okay students. Now multiply both sides with I. So if you multiply both sides with I, you get I Z square, which is equal to, so what I am doing, I am multiplying both sides with I, so that here you get I square Z square, and here I into Z bar. Hereafter what did I do? I multiplied both sides with I. Here I into I square and Z square. Here I into Z bar. I square, which becomes minus 1. So you get minus Z square, which is equal to, so here Z bar, I Z bar. Now multiply both sides with minus. Z square is equal to minus I Z bar. Now multiply both sides with one more Z, so that here you get Z cube, which is equal to minus I into Z bar. In this step, what did I do? Both sides I multiplied with Z, so that left side became Z cube and RHS Z into Z bar. Okay students. See, in the next step, so Z into Z bar is a real number. Okay, Z I multiply with whose conjugate. You may get any real number, but here I am taking that real number as 1. Suppose if Z into Z bar equal to 1. Here we don't want the roots of that equation. How many roots does it have? We have to find. Okay students, see, find the number of distinct complex roots of the given equation. So that is the given problem. So here we don't require the roots, but how many roots does it have, we have to find. So that Z bar, it is a real number. That real number you can take any real number. So here I am taking that real number as 1. If you write this part is 1, then you will get Z cube is equal to minus I. Okay students, in place of this I kept 1. Actually this is not equal to, either it may be 1 or any other real number. Just to make this simplification as easy, this part I have taken as 1. So then it becomes z cube equal to minus I. Now this minus I you can write I cube. Shall I write? Because I cube, you know, I square into I. I square value minus 1. So minus 1 into I, which becomes minus I. So that you can write this one as like this. Now bring it to the left side. Z cube minus I cube, which is equal to 0. Now factorize it. Z plus I. So here Z minus I into A minus B into A square plus AB plus B square, which is equal to 0. Now see, equate both of them equal to 0. On equating this one equal to 0, you get Z is equal to I. On equating this one equal to 0, see students, Z square plus IZ, so minus 1, which is equal to 0. Now that is one quadratic equation. Now solve it. Z is equal to minus B plus or minus root of B square minus 4AC. So which becomes 4 by 2. Okay, still if you want to simplify that, you can, otherwise you can leave like that. Because here we found one complex root, Z is equal to I, and here if you take one you get one complex root, and if you take minus, you will get one more complex root. So totally we are getting 3 complex roots for this given equation. Still if you want to simplify this, you can. Z is equal to minus I plus or minus I square minus 1. So 4 minus 1 root 3 by 2. Okay students. Now Z is equal to minus I plus root 3 by 2, and Z is equal to minus I minus root 3 by 2. Okay. So if you want to multiply, okay, so this one with, see still this you can express as I omega, this one I omega square. Just you know, omega is one of the cube root of unity. If you multiply that one with I, you get this, you know, omega square. This is also one of the cube root of unity. If you multiply that one with I, you get this. Okay students. So how many complex roots have we got for this equation? 3. Here we found 1, Z equal to I, and here I omega and I omega square. Okay. So these are the 3 complex roots, I omega and I omega square. Okay. So if you want, you can check it here, omega value. So minus 1 plus root 3 I by 2. Now multiply I with both sides, it is going to be I, and here if you multiply I with both sides, here it is going to be minus root 3 by 2 students. This is I omega and this is I omega square, sorry. Okay. So these are the required required complex roots of the given equation. What are that? I omega square. I hope you have understood this solution. Thank you.